Hello, welcome back to the next lesson of GCSE Geography. We're going to look at flood management strategies today. So what we mean by flood management is humans have built most of their towns and cities close to rivers because it's flat and easy to build on. The soil is super fertile from all the silt that's been dropped by the floodwater, as we discussed last lesson when we were looking at the Aswan Dam. It's close to the river for a water supply, and you can transport and trade goods up and down the river. So there's loads of reasons why humans deliberately live close to rivers. But of course, that then puts us at high risk of flooding. So we need to manage that risk. Managing risk means putting things in place to try and stop something happening so that there is no risk posed to humans anymore. So what we're going to do today is identify the differences between the main flood management strategies that are used to reduce flood risk. They fall into two categories: hard engineering and soft engineering. And what we're then going to do once we've looked at the strategies is evaluate what's good and bad about each one, which one might be better than the other from various points of view. So go ahead and write down today's title, Flood Management, in your books, and we'll get going. Okay, so we're going to go straight into looking at the first method of flood management is hard engineering. Okay, just from looking at these images, what do they all have in common? Okay, this is a flood wall. This is what we call an embankment. These diggers are digging out the river channel, and this is a massive dam. What do all these have in common compared with soft engineering strategies? Planting trees, afforestation. Washlands, so just leaving the land alone to flood in some areas to absorb the flood water before it reaches the towns and cities. Warning systems, so like when the Met Office issues an amber flood alert or a red flood alert, giving you warning systems and warning time to evacuate. And what we call land use zoning, so mapping out the highest risk areas and then just don't build there in the first place. Something is only a hazard, it's only a risk if you're in the way. So don't build in areas that flood. No more flood risk. What do you think from looking at these examples compared with the hard engineering examples? If I go back to the previous slide. What's the difference between these two approaches? Okay, if you're thinking anything along the lines of one appears to be more man-made than the other, one changes the river in some way, affects the river directly, controls the river in some way, whereas the other one works more with the surrounding land, then you're kind of along the right lines. Hard engineering strategies, building flood walls, embankments, digging out the river, building a massive dam, these are all man-made strategies that impact or change the river channel itself in some way. Now, because they do that, they're often the most effective strategy, I'll be honest. They either block the water, they increase the capacity of the river, they tend to be the most effective at stopping floods from happening. However, because they're man-made and because they change the river directly, they're not very environmentally sustainable. We've talked about the word sustainable before. If something is not environmentally sustainable, it's having a lasting impact on the natural environment. Obviously, this is going to destroy the river ecosystem, digging out the riverbed. There's a lot of changes being made, okay, with man-made materials. So hard engineering tends to be more aggressive, not as good for the environment, but very, very effective. So from an economic point of view, money, protecting homes and businesses, and stopping loss of life, so from a social point of view, these are potentially more sustainable. Let's walk through them. So this is a flood wall. Now, flood walls quite often are either built of metal, as this one is, or sometimes they might actually be panels of glass. Now, they effectively create a barrier. They block the flood water from reaching homes and businesses. If you're protecting homes from flooding, what that tends to do is stop people's home insurance costs from rising because they're not at risk of being flooded as much. If you're not having to pay massive home insurance, that means you've got more what we call disposable income. It means that your bills aren't too high, so you've got more spare cash to spend on nice things, and that improves your standard of living. We've started using terms like quality of life and standard of living. Quality of life, how happy and healthy you are. Standard of living, the nice stuff that you have. How nice is your house? How nice is your car? Do you have spare money for nice things? And if there's a flood wall in your area, it protects your home. Home insurance cost is therefore lower because you're at lower risk. Lower bills, more spare cash. Higher standard of living. You can buy nice things. However, flood walls, you can't really build them too high because they tend to be built in areas where the river already runs through a town. So you can't go building a massive wall here. Because you can't build them too high, it's only going to protect from a small flood. Plus, they're not actually very nice to look at. A lot of people that buy homes close to a river, it's for the nice view, right? So building a massive metal wall there is what we call visual pollution. Local residents might not be too impressed, even though it's protecting their homes. Dredging. You're digging out the riverbed, so you're essentially making the river deeper. If something can hold more, that's called its capacity. So you're increasing the river's capacity here. It can hold more water before it overflows. So it's quite effective in the short term, very quick and easy to do, literally just pull in a couple of diggers and a couple of workmen, job done. But in the long term, rivers will deposit their load and the riverbed will fill back up. So you're going to have to repeat the process, which could make it expensive in the long run. Plus, you're destroying the river ecosystem here. You're literally ripping it out. So this is not environmentally sustainable. This here is an embankment. They're normally made of natural materials. So that's good for the environment. It's normally just mud and sand and rocks. In fact, quite often, it's the mud and sand and rocks that have been dredged out from the riverbed. So dredging and embankments, quite often you'll see them in the same place because you just dig the material out and put it on the sides. And it works in a similar way to the dredging. You're increasing the river's capacity, but this time, instead of digging it deeper, you're making the sides higher. You're increasing the height of the banks, so the river can hold more water before it overflows. Natural materials, good for the environment. Quite often they'll build a walkway along here as well, so it's quite good for the tourist economy. You'll get walkers and visitors and things like that will spend money in local businesses. However, because it is natural material, when this river is flowing higher and it's in flood and it's flowing fast, high velocity, high energy, you're going to get erosion of these embankments going on. So it's going to need maintenance and replacement in the long run, which could become expensive. So it's not economically sustainable. Finally, we've got a massive great dam here. This is perhaps the most effective way of managing flood risk because you're essentially giving yourself 100% control over that river. You build a wall across it, you control, well, computers that are run by humans control how much water you let through that wall. Now, therefore, homes and businesses 100% protected. However, number one, it's the most expensive method. So for LICs, low-income countries, this may not be viable. Number two, when you build a wall across a river, behind that wall, the valley is going to fill up with water. It's called a reservoir. And it's likely that that valley was either, certainly at least home to animals. You've destroyed a load of habitats. Quite often it would have been home to people too. It's not uncommon for there to be old homes at the bottom of reservoirs, and that land might have been used for agriculture. You might have put a few farmers out of business there. Also, concrete is a man-made material, and it's one of those man-made materials that during its production, while you're making it, it releases carbon dioxide. Carbon dioxide is a greenhouse gas, which contributes to climate change. So, might not be so good for the environment. However, as we discussed in the As One Dam lesson, you could build a power station into the bottom of this dam that produces HEP, hydroelectric power. This is a renewable source of energy that produces no greenhouse gases at all, no carbon dioxide, no nothing. It's green energy. So you could argue that the CO2 released during the production of the concrete to make the dam is then offset by the fact that you're producing clean green energy through the production of hydroelectric power. So upsides and downsides to these ideas. Very effective, not so great from an environmental point of view. Conversely, soft engineering tends to be the opposite. These are often very cheap, very simple, and far better for the environment, but in some cases not as effective. And the main difference is that you're working with the surrounding area. You don't actually really interfere with the river in any way. So one way of doing this is afforestation. Super cheap, super simple. You just plant trees. Now, we've discussed before the benefit of this with regards to interception. So when it rains, the trees will intercept the rainfall and therefore slow it down from reaching a river. And this gives the river channel time to cope with the extra water that's coming in. So it slows down the water, it gives the river a chance. And essentially you're creating a habitat. So super good from an environmental point of view. However, planting saplings, baby trees, is the most affordable way of doing this. If you're going to plant adult trees, it's actually very, very, very expensive. So because you're planting saplings, as shown in this image, it's going to take time for those saplings to grow to a size that actually causes sufficient interception to have any impact on the flood risk in the area. Plus, in LICs, what can often happen is in poorer communities, they need fuel wood to keep warm and to cook meals, and they need wood for building materials to build their homes. So sometimes afforestation projects fail in LICs because people go along and cut it all down to keep themselves warm, cook their food, or build themselves a home. We've got a washland strategy here. So what you do when you're looking at building on a floodplain is you leave some areas of the floodplain as natural wetland, natural washland. So when the river floods, there's fewer areas that are impermeable. You've left the natural soil surface here, so there's plenty of infiltration and the flood water will drain away quicker. However, if there's a really extensive flood, this doesn't actually do anything to stop the flooding. The flood water could still saturate the washland and then flood into the urban area, as you can see in the background here. Although it does protect wildlife, you're leaving a natural environment intact, but it doesn't do much to protect homes and businesses. This is an illustration of a warning system. So what happens here is meteorological societies, meteorology is the study of the weather, so places like the Met Office gather lots of information about approaching storms and then give out flood alerts and flood warnings to different areas of the country. And they are colour-coded to indicate the likelihood and severity of the flood that might happen. And what this does is gives people advance warning so you can get out the way. You can evacuate. So this is great for preventing loss of life, but it does nothing whatsoever to protect homes or businesses. The flood is still going to happen. So from an economic point of view, protecting people's jobs, businesses, income, protecting their homes and therefore keeping home insurance costs low, not going to happen. Businesses are going to get destroyed, people are going to lose money, home insurance costs are going to go up. So not great from an economic point of view, but it will save lives. Finally, we've got land use zoning. Now what this does is it collects historic flood data in an area. So say somebody's looking to build a new housing estate, or you're looking to extend the edges of a city onto the surrounding land due to population growth, you would first look at flood data for the land that you're about to build on. That would give you an indication of which areas have the highest flood risk. So dark blue, floods a lot and floods badly. Light blue, medium risk. No blue, low risk. And what you then do is you just don't build on the high-risk areas. Something is only a hazard if you're in the way, all right? Tectonic hazards like volcanic eruptions and earthquakes, it's only a hazard if you live in an eruption zone, in an earthquake zone. It's the same with flooding. So if you identify areas that flood and then don't build there, you eliminate the risk altogether. So highly, highly effective. However, population growth is one of the main issues facing our planet. We need more homes. Our towns and cities are growing. If you identify areas that are higher risk to live in, everyone's going to want to live in the low risk areas. And that's going to mean that any housing in the low risk, safer areas is going to become very, very expensive and therefore unaffordable for first time buyers, low income families, for a lot of the population actually. So although this is a good prevention method, it could actually create other knock-on problems. What I've made for you is a text that has everything in that I've just said, basically. Okay, so in one of the handouts, you've got this text. Now, I've only screenshot part of it, so don't read it off of this slide. Read it off of the actual handout. And what I'd like you to do is 3 things. Try to identify how each method works, what the advantages of each method are, and what the disadvantages of each method are. Whether you want to use 3 different highlighters or 3 different coloured pencils to underline or whatever, go through the text and pick out the main points. How do they work? Upsides, downsides. Pause the video now and do that, please. Okay, so now that you have selected that information, we're going to summarize it into 2 tables in your books. Okay, take a whole page turned sideways. Put a heading hard engineering. Set out this table across the entire page. In your handouts, you've got pictures of each of the methods. Cut and stick them in there. Put a little summarizing sentence of how each of them works. And then bullet point notes on the advantages and disadvantages of each one. Now, whenever we're picking out the good and bad of something, what are we doing? We are evaluating. Okay. Now, this is a note-taking table. So as I've mentioned before, if you want to use like dash symbols or equal signs, that's absolutely fine. So for example, with dredging, a disadvantage, you could say destroys riverbed, ecosystem lost, wildlife species decline. Okay. With a dam, in disadvantages, you might put made of concrete equals CO2 released equals adds to climate change. Okay, so bullet points, dashes, whatever you want to put as your note-taking strategy is fine. And then do exactly the same for soft engineering as well. Take a page, turn it sideways, draw out this table with the heading soft engineering, match up the images in here, and then take the notes that you've selected and summarize them into the table in bullet point note-taking form. Okay, so pause the recording here. 2 pages, 2 tables, 1 evaluating hard engineering, 1 evaluating soft engineering. Bullet points and note-taking shorthand is fine. Okay, now that you've got all that information, I'm going to give you another past paper question. You've only tried one of these so far, way back when we looked at national parks. This one is also one of the highest, well, it is the highest marking question you can get. Okay, you'll see it's worth 8 marks there. There's a way to go about answering this style of question. Okay, so it gives you a statement, and then it asks you whether you agree or disagree. In this case, the statement is, hard engineering methods are the most sustainable strategies for ensuring the economic future of an area. To what extent do you agree? Justify your answer. So, to what extent? What does that mean? All right. Do not sit on the fence. Do not go, well, I kind of agree, but I also disagree because... No. You have to choose. You either strongly agree or you strongly disagree. Now, the good thing is, it doesn't matter whether you agree or disagree. This is the secret. Justify your answer. You have to back yourself up. Why do you think what you think? Okay? Now, this statement, what it is essentially saying is, hard engineering is better for protecting money interests in an area. Okay? So that's what your answer is going to focus on. All right? It's mostly the economy. So we're talking about what's going to happen to businesses, what's going to happen to people's jobs, what's going to happen to people's bills, people's income, anything to do with money. Now, there's 4 sections to this type of question every single time. First off, do you agree or disagree? Do not sit on the fence. All right? Your very first sentence will always be, I strongly disagree or I strongly agree. Either one. The next thing you do, 2 or 3 well-elaborated reasons why you think this. So I want to see lots of elaborating words like this means, therefore, as a result, so, consequently. The next thing you do, 1 or 2 well-elaborated points that acknowledge the opposite. What I mean by that is, if you have agreed, then you're going to say, however, I do recognise and give a couple of the opposite side of the point. Same if you've disagreed. Give a couple of reasons. You can see the other side of the argument. And then finally, a conclusion. Literally 1 or 2 sentences that reinforces what you think. Okay? Pause here a moment. Copy down the statement and the question. So just this top bit here. If for future reference you think it'll be useful, copy down this strategy as well. We will be coming across this a lot, so don't worry if you don't copy it down right now, but pause here and at least copy down the question. Okay, I'm going to give you a writing frame to guide you a little bit more because this is the first time you've attempted a question like this, and it's the highest type of question on the paper. All right. So there's your part 1. I strongly agree with this statement, or I strongly disagree with this statement. For example, so say for example I strongly agree. Hard engineering is the best way forward for protecting money. For example, a dam works like this, which means, therefore, as a result, secondly, flood walls mean this and that and the other. Another example would be dredging, which, therefore, as a result, okay. However, I do recognise that hard engineering sometimes isn't a very good idea. For example, from an environmental point of view, the carbon dioxide, blah, blah, blah. Okay, and then I'd say in conclusion, I really feel that hard engineering is best because, and summarise what I've just said. You can disagree. You can go for, no, I don't think hard engineering is the way forward. I think soft engineering is better because, right? Either way, the secret is all in this middle part. It's all in your justification. So pause here and give it a go. To be honest, if you're writing more than a page of A4, page and a third maybe, you're probably waffling. Maximum. Pause here and give it a go. Okay, so what I'm going to do with you, last thing, is run through a model answer. Now, you do have a copy of this answer on your handout. I'm hoping you didn't twig at the beginning and use it to cheat. But what I'd like you to do is cut and stick that model answer in now. I'm going to walk you through it, what's good about it, and then I want you to go back to your answer and add or change anything that you feel needs to be added or changed to make it an 8 out of 8. Okay? So, part 1, I strongly agree. I think hard engineering is best for protecting the economic future of an area. And I've gone straight into my first reason why. For example, I've given a little introductory sentence here. Hard engineering is better from an economic point of view as it is effective at protecting land use, such as shops and businesses, because it actually prevents a flood from happening. What I've done here with the introductory sentence is just shown that I'm 100% clear that the question wants me to focus on the economic side of things. Okay. For example, a dam controls the river completely. I'm going to get a mark there. This means people's jobs and therefore income is protected. Another mark. So families do not lose money. and their standard of living remains high. Another mark. Nice key term too. Here's another reason for a flood wall. This protects homes nearest to the river, so home insurance costs will be lower. Another mark. This will mean a higher standard of living for local residents because their bills will be lower, so they have more disposable income. Another mark. So I'm up to 5 at this point. However, I do recognise hard engineering methods may be very expensive and can have an impact on the environment. For example, the concrete used to build dams releases carbon dioxide when being built. Another mark, which can contribute to climate change. Now, this is an 8 marker. To get 8 out of 8, you have to link to what they call a wider concept. Wider concepts are things on a larger scale like climate change, the water cycle, nutrient cycle, carbon cycle. We'll come on to those later. So although I've gone off on a tangent about the environment a little bit here, even though the question wants me to focus on economic, I've linked to a wider concept, and then I've shown even greater understanding by saying that actually there's a solution to the drawback that I've just pointed out. The hydroelectric power produced is a renewable energy and releases no greenhouse gases, so it may help to offset this problem in the long run. And then I've put a conclusion. Literally one sentence, super effective. In conclusion, overall, I believe hard engineering is more sustainable from an economic point of view as it protects income for businesses and can save people money on home insurance bills. So I'm reinforcing that I understand it's all about money, and therefore it's all about businesses and people's income and bills. All right. So there's part 1. I agree or I disagree. These 2 paragraphs are part 2. Well elaborated reasons, lots of key terms. Here I am acknowledging the opposite. I think hard engineering is better, although I do realise it can be bad. But I've then said how the bad point that I've highlighted can actually be resolved, which is quite high level, and I've linked it to a wider concept. If you haven't said anything about climate change anywhere, you're capped at I'll explain more in person when we see each other how it's marked, but you'd be capped probably at 6 out of 8 if you don't link to a wider concept in an 8 marker. And then a really succinct conclusion. Okay? Go back to yours. Are there lots of key terms in there? Have you elaborated your points far enough? Have you covered all 4 sections of this style of question? Have a little look, add or change anything that you think needs changing. And then that is the end of lesson 9. Well done. Don't stress about anything, just be positive that you're even giving all of this a go, trying to learn under these circumstances. As usual, drop me an email if there's any questions, queries or worries at all. You've just kind of peer assessed that past paper question. I will take your books in pretty much as soon as we get back to mark everything that we've done so far and plug any gaps and get us all up to date and up to scratch.